contribution, they ensure that my contribution should be there on it. Okay. Well, before actually going into this, okay, this is a very special day as far as our engineering community is concerned. Okay, it is the birth anniversary of the great, well-known engineer, okay, Dr. Visvesvaraya. He's a person, okay, he has maintained a life. That's how should we live, okay, and how should we follow? How should we follow? Like that, okay, the number of things, whatever it has been carried out, okay, and how he has maintained his life, how he has maintained his personal life, and how he has maintained his the official life, and how he has moved with other peoples. That is a lesson we must learn, and then we must follow also. We must follow also in while going through the any of our going to our actual life. In this session, that what I have planned this. Okay, I am planning to take, okay, two part of my lecture is on two parts. One is on the first on the general topic, and to commemorate the session of the birth anniversary of Dr. Visvesvaraya as an engineer's day, and we engineers we are proud to follow that. Okay, first we will see, okay, some amount of time, spend some amount of time bringing some memories of Visvesvaraya and how he has maintained it, how he has inculcated, and what should we follow as an engineer, what should we follow. Okay, what is our role of engineers? Okay, so that we have to take it, and then we have to proceed further on it. Okay, so this session, okay, what we are going to take, okay, is something like, okay, first session on 1 minute. Let me share my screen, then it will be easier.
Yes, Deepak.
Yeah, can you see the screen?
Yes,
Yeah,
sir.
Yes, sir. Thank you.
yes,
So,
sir, just double click.
double click.
Yeah, yes, sir. Engineers Day, the menu will be there, but
Okay.
PowerPoint will not open, sir.
What do you have to do?
Yeah, double click பண்ணுங்க sir. Engineers Day Sairam double click பண்ணுங்க sir. .ppt.
Okay, okay, okay.
PPT you have to open, sir. Yeah.
Opening. Opened.
No, sir. That folder will show, sir.
Yes, share all there. Your screen sharing on there.
The screen sharing is option there, but இந்த folder மட்டும் தான் எனக்கு காமிக்குது. இந்த folderல வந்து நீங்க என்னென்ன PowerPointல வச்சிருக்கீங்களோ அது மட்டும் காமிக்குது எனக்கு.
Oh, yeah.
வேற ஓபன் பண்ண ஸ்கிரீனை வந்து நீங்க கிளிக் பண்ணுங்க சார். PowerPoint ஓபன் ஆன ஸ்கிரீன்.
Okay.
ஃபுல்லா இல்ல க்ளோஸ் பண்ணிட்டு திரும்ப ஒரு தடவை பண்ணி பாருங்க சார். மெனுஸ் மட்டும் க்ளோஸ் பண்ணிட்டு.
எங்களுக்கு டீம்ஸ்லாம் we are very familiar with the team.
Okay.
Microsoft.
Yes, sir. Yes, sir.
Okay.
Windows team, Microsoft Windows team.
ஆமா. Okay, that's what we are.
This Zoom is licensed version. That's why we are using that. Let's stop sharing பண்ணிடுங்க சார் ஒரு தடவை.
Stop share போட்டேன்.
Okay, stop sharing. And once again you go to ஃபர்ஸ்ட் ஓபன் பண்ணிட்டு அப்புறம் ஷேர் கொடுங்க சார். ஃபர்ஸ்ட் நீங்க உங்களோட சிஸ்டம்ல ஓபன் பண்ணிக்கங்க.
Oh, right. Okay. I got it now.
Yeah. Yeah, yes, sir. Yeah, happy Engineers Day. Slide will be
Yes,
visible.
yes, yes, yes.
Yes, sir. Thank you, sir. Thank you, sir.
Sorry for the troubles. Okay.
No issues, sir. Thank you, sir. Thank you, sir.
So again, once again, it is my pleasure to wish everyone, our fellow community, engineers community, okay, happy Engineers Day. And okay, so who says that? This is the gentleman. Okay, we have Moksha Sundam. Okay, Moksha Gundam. Okay, Viswaresaya. And it is his birthday. Okay, September 15th, 1860, April. He has born it. Okay, and this man, as if we see that, okay, as born in a village, okay, that's his residence that is found there in Mudanahalli village, okay, in Karnataka, Kolar district. And the father is in a, okay, yeah, well, okay, educated community, I can say that. Okay, father is in Srinivasa Shastri, and the mother is in a Chamba. Okay. He had a very, he's not an, the pleasant life, he has not a, had a, didn't have a very pleasant life as far as, okay, or a luxury life, not pleasant life, we can say that. Anything we can take it as pleasure, okay. Yeah, luxurious life as like we used to have. Okay, those days he used to study under street lights and then he has come to that level, okay. He had his early child, schooling in Chikaballapur, okay, that is a near district, and then he had his BA examination. Those days we have used to have BA and then engineering, something like that. BA examination from Central College, Bangalore, and 1883, okay, civil engineering from Science College in Pune, okay. And that time, okay, the civil engineering is comes under science faculty only, okay. So even you can see many of our senior professors used to have MSc engineering, BSc engineering, something like that. Okay, and he ranked at the first in the LCA and the FC examination. That is something like our okay, equivalent to our examination today, B examination. These are the some of positions. Okay, has rose to a very different level, and also a minister. Okay, assistant engineer and government service. Okay, chief engineer Hyderabad State, and he is chief engineer in Mysore State. And okay, he was also secretary to the railways, president of education and industrial development committees in Mysore State, and Diwan of Mysore. So, okay, that's very great post, Diwan of Mysore for 6 years. And then chairman, okay, Bhadradi, member of governing council, Indian University of Science, Bangalore, okay. And then, okay, there is a different building there for Viswaresaya, also in IAC. And the member of the governing council of Tata and Steel Committee, member of Backway Inquiry Committee, member of committee, many committees he has. But, okay, all these he is having with certain values. Yes, attached certain values. Attach certain values, okay, not only simply we won't get it, okay, only we must thank to their parents, okay. So without them, without even ourselves also, without whom we would have not come to this position, we have not attained this examination without their dedication. So like that, okay, he also had his father and mother, okay, and in a joint family system, he has grown up. Okay, those days only they only joined. Now only we have used to have flash system where we used to have. Okay, we may not know who is there at the side, and even may not know who is there within our family itself sometimes. Okay, and this is what happening is, see, we have our son or daughter somewhere there, we must ensure that okay, what is our family, what is our background, what is our how far we have come, how we have come to the life, how far we have succeeded in it. All this must be okay, must be passed on to our community, okay, our generation. Then only they may know the value that is attached. What is the value that we have given to them, and what is the value that they have to pursue in their career, that you must know. Okay, this what, okay, why we are celebrating all this, okay, the engineers day or teachers day, okay, both are falling in the month of the auspicious September month, okay. So why are, okay, they have had some, okay, the habits, that habits must follow, must follow. So that's what is there. Okay, in the side you can see that, okay, there is one okay clock, and this one is given. The reason for it is nothing but, okay, it is nothing but, he's a very functional man, very functional in the sense that, okay, uh, okay, even Vinobaji once he went there to meet, okay, and then he was late. Vinobaji was late to do some reason, some valid reason only he couldn't meet him. He went late, but he refused to meet it. Okay, that is okay, the culture he had. That is a habit he had. Okay, similarly, okay, it is given here. Okay, he had, okay, once a minister came and then he asked, okay, you should not commit this mistake. You have committed a double mistake. Firstly, by not keeping up the engagement yesterday, and secondly, by coming when you are not. Okay, so that man, okay, what happened? Even I used to say, even this is in our mind even, okay, I my education, all those things, okay, and okay, after BS only I did my BTech, but even after 35 years or even so, I still has in my memory, okay, during my second year of BSc, okay, in Sacred Heart College, Tirupattur. No, what no? Okay, we used to play in the evening around, okay, up to 6 o'clock we are allowed to there, and then at 6 you have to inside the hostel. 6 to 7:30 is the study hour. Okay, that is a culture that is maintained. That is a discipline they maintained. The discipline only now brought me to this level. Okay, I am proud to say that. Okay. So one day what happens, okay, the game, okay, the last game was little bit longer, and after that we had a tea and then we are late by almost 5 minutes. The father, no, okay, father used to, Chalician fathers only there. He just waited outside and said, okay, we expected that he will scold like that, okay, but simply say that, okay, he simply said, okay, nothing. While we are passing out, okay, just as we are 5 or 6 are in a group, okay, and then when the last man passing out at that time, he murmured, Sunday pardon. Okay, so only these two words. Okay, but how much it has its value? Still, I am able to recollect those words. Okay, Sunday pardon. Okay, and that's why. Okay, this. Okay, these are things that is brought up. Okay, brought up to us. Okay, so that's what the maintaining a punctuality. That is another good character what he has maintained. Okay. What is that? Okay, even okay, he was given an opportunity, okay, to implement an irrigation project in somewhere in an African country. No, 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 not like that. Okay, we went there in African country, and before that, what happened? No, it is something like before actually going to the site, there's a ladder was there. It is a floor that is he has to climb over this one. He was around 95 or so. That stage only went there. Okay, everybody was amazed how this okay, world man is going to land up there, land up there. But he said, okay, he didn't expect. Okay, he's all of a sudden, okay, all of a sudden just climbed over and then at the top. Okay, so that is the zeal he has said. Okay, zeal is there. Okay, so that's what he is there. Slackness is the worst curse of the country. Slackness is the worst curse of the country. And that's what he used to say that, okay, whether you are doing a duty of a floor man, floor cleaning man, or a high official, okay, you should have an ethics. You should have certain codes, certain ethical codes that should follow. That should follow. So that's a picture that is shown that, okay, you can see that, okay, with along with Nehru, okay, celebrated a 100th birthday. At the age of 90, a friend asked him how he felt under them. He remarked, I find life interesting. See, we used to have it even at the age of 60. Once, okay, 60, okay, I'm in the retirement stage, okay, and our life is over. But he has not meant like that. Okay, he's still, okay, he made the wheel to rotate, okay. And also, he's a man, okay, with, okay, gives so much importance to his dresses. Okay, dresses matter. That's what Rajesh once, even if bring him a photograph in the middle of the night, I can take your pictures. You will always be well known. Like that, okay, yes, sir. Mentioned. Okay, man with values. You see that, okay, the doctor suggests him take a few drops of brandy. Okay, that's what. He's a teetotaler. Okay, it's a teetotaler. Okay, and then what will happen? The man that suggested him take just a little bit of brandy with some medicine. He replied that if this life cannot survive without these drops, let it go. Okay, matter. So like that. Okay. On his account of book, he has written, if you buy what you do need, yeah, these are the things that we must keep. If you buy what you do not need, you will need what you cannot buy. Okay, the simple words, isn't it? If you buy what you do not need, you will need, okay, what you cannot buy. Okay, so whatever you spend here, and then since it will, okay, in future may not buy. Maybe was one of those rare human beings who practice in personal life what he preached in life. Okay, now it is not something like what our politicians used to do. Normally they say a lot of things. Okay, that is for the public, not for his personal life. Okay, and for his, but he is a man with a character, and they said that he has followed the whatever he said that is there. He introduced the block system of irrigation. Block system of irrigation. Okay, so what will happen now? I have given a small slide. Okay, what actually a irrigation system is there? Okay, so that will give an idea how he has gone into that, what amount of work that he has done, that we can appreciate only with this one. You see this, okay, here. Okay. So what is that? There is a reservoir somewhere there. From the reservoir, we have to pump it. As a pump it, what will happen, we should be taken to a canals. From the canals, what will happen, we should maintain another sub-canals like that. We have to distribute it. And then we should maintain a drainage system to maintain the safety of the, okay, the reservoir. And then once it is taken, then what will happen, the distribution that should be taken. Okay, block distribution there. From the block distribution, then field application system that comes. Okay. So he has blocked it. Okay, he has blocked by block. Okay, he has okay taken that, and that's what is there. Okay, so this is the intake structure. Intake structure. In the intake structure, okay, from the intake reservoir, he takes it. That is, takes and then take it to a canal, and the later canal will be. He said, okay, what will happen now? It is goes through a pumping station. From the pumping station, it goes to the irrigation system, and the irrigation system that goes to a canal. The canal structure may be a different type. We are not civil engineers know much better about this one. And something like this, we have, yes, okay, yes, okay. So in a Mysore district, he has maintained this. He has maintained this, and he is the root cause for the KRS dam. Okay, we are also getting benefited. Okay, Tamil Nadu is also getting benefited the KRS dam. Okay, and then Bhadravati steel chairman. Okay, he rescued from becoming extinct. Okay, so almost the steel industry, that is this Bhadravati steel, almost gone to an non-existent. And then what they rescued it and then bring it to gave life to that, gave life to this. So like that, this gone, okay, gone into this. So that's what. Yeah, design a new system, a systematic walkway floodgate. Okay, and then establish a Deccan Club in Pune. Okay, whatever there, okay, yes, maintained. Okay, these only years together. Okay, it is maintained, or rather we are using that. We are using that. And then he has selected a site for railway bridge on river Ganga in Bihar, Hirakud queries, water supply system, like this goes. The long list that goes on. Okay. Then the major achievement, that is the Krishna Raja Dam and the Bhadravati steel plant, and then he has introduced the State Bank of Mysore. Okay, State Bank of Mysore, founder of Mysore Sandal Oil Factory, Mysore Soap Factory, and Mysore Chamber of Commerce, founder of Control Literacy. He has done a lot. Okay, there was even one conception, misconception that, okay, he has made it, okay, only he has done a lot to the Karnataka state North-Hills. Not like that, okay, we should not think that sales. Whatever the benefit that he has gained, from the knowledge, whatever it is gained, it is passed on to the entire world, and then it is being passed, it is being, even that's what, during one time, what will happen, he was, okay, he was working under a Englishman. All the Englishmen, okay, he was went back to London, and during that one he was able to present. That is, he has to present something, some memento to you. And as the Englishman went there, and then unfortunately he passed away. But what happened? His wife took care, and then came back for this purpose. Came back to India, and then met the Visvesvaraya, then gave it. Gave it. Okay. So that's what it is, something like this. Okay. So this quote, if Australia, Canada could have universities of their own for less than 1 million people pollution. Why not Mysore have a population? That's what he initiated, and then okay brought it. Okay, the Visvesvaraya University and other. Okay, he makes a great dream. Also said India prosper through industrialization. Okay, if we go there into Bangalore and then Visvesvaraya Technical Park is there, we go if we happen to there, but don't miss it. Okay, that's a good one, very good one. And then okay, so you must see the what is the concept that he has in mind, and then all this. He coined the slogans. Okay, he coined the slogans. Produce or perish, and industries are perish. Industries are perish. Okay. So this has gone. Okay, and then he has awarded so many awards. Okay, so many awards. This is the Knight Award. Okay, Knight Award that is being presented to him by the English government. Government. Okay, and then DSA in Calcutta University. Okay, like that, and the honorary member of London Institute of Civil Engineers, and most among them, most coveted one. Okay, the what is that one? The Bharat Ratna. Bharat Ratna that is being. Okay. So like that, many awards that is okay. He is receiving the Bharat Ratna from I think from Rajendra Prasad. Okay, the award that is he is receiving. So these are the memorials and then institutions in his memory that is still it is working. One is very famous on that one is the Visvesvaraya Technical University in Belgium. Under that only like another university there are many colleges are coming under this. Okay. So there are colleges among the Visvesvaraya National Institute of Technology, University of Visvesvaraya College of Engineering that is in Bangalore. So these are some of the institutions. And his alma mater is okay, Pune. He has erected a statue in his memory. These are the things, okay, and then okay, he has made it. Okay. This is okay. Okay, he has the 1962. Even I was not born. Okay, just a year after only I born it. Okay, but okay, he just at 6 p.m. Okay, at the age of 1 or 2 years. Just think it. Okay, we are even okay struggling with 60 years. At 1 or 2 years, okay, the yes, right? So with that, okay, what happened? We engineers, okay, what civil engineers exactly we do, and then what the electrical engineers can do, and then what the mechanical engineers, okay, we can move the world, and then we can bring the computer engineers, okay, computer science, and then magic, we will build a magic world, and then we can connect the people on it. Okay. So these are some of the lectures that is being taken from the okay, and in the net only. Okay, nothing new. I cannot boast that I have made it. It's not like it is taken from there only. Okay, any engineering oriented topic we can do on our own and then present it. On a general topic, we have to look at the resources in that way. That's what we do. Now, what is the role of engineers in the national economy? Okay. For a role of engineers, this will take another 10 or 15 minutes. Then we'll move on to the topic what we are discussing. The topic of the so the creative application of scientific principle to design, develop structure, machines, apparatus, manufacturing process, okay, our works utilizing them singly or in any part of the walk of a life in a societal system, okay, to construct, operate the same with the full organization, something like this. Okay, this is a full-fledged definition. One practices above these practices, we will call it as an engineer. We call it as an engineer. So engineers, okay, we cannot work. Okay, that's what science background. Without science, we cannot do anything. From science principle, then what will happen? Science principle, then what will we have to take the principle and then apply this one. Apply this one. The technology helps us. When the technology that is given, then how it is being applied to us? Okay, then engineers will do it. Okay. So what is that? That's what is given. Engineers borrow. Engineers borrow from physics and mathematics to find suitable solution to the problem and then okay. Not only physics, okay, sometimes we are learned like that physics, those days only physics, chemistry also. Without chemistry, somebody is having a concept that one, okay. Without physics, we are able to do it. Without chemistry, we can do it. Okay, with the chemistry, all we have to do it. See, the whole body is of a chemistry. The whole body is of a chemical reaction. If it is then without a chemistry, and then how these okay with this even if we have this one, chemistry also needed to find a solution for it, especially mechanical engineers definitely. So what we do, we design, create, explore, innovate. Okay, So engineers receive education in many different fields. They work in many different environments. Engineers do things make world worthy of living. Okay, that is our prime objective. We make the world okay worth of living, worthy of living. So in order to do this, okay, what will happen? Our major roles are three roles are there. Okay, one is a technical role, another is a social role we have. Okay, social role we have, and then okay, an economical role, and then social role, social, technically social, and then economic, which is it put our mind into this one. Okay. And then how we have done some work in this one. Okay, that's like instead of just focusing that how it is used in our engineering society, especially in teaching community. How we are engineering bridges the gap between the society and the scientific knowledge. Okay, what happened now here? See that there is a scientific need, a social need. Okay, there is a social need. For the social need, there is a science knowledge available, scientific knowledge is available. Now apply this scientific knowledge, okay, engineer this, okay, put it in a proper way, engineer this science knowledge for the societal need, for the societal. So that's what happened now. Nowadays, it is given a good name for it, and then we are going for it. We are going for it. The major problem is that one, there is a gap, okay, in our engineering community, in our Indian engineering community, as that what actually social need is there, what sort of social need that is existing, what is the social problem that is existing, and then how to overcome this one, and then okay, how to get know about this one, how to get know. So that's what will happen in Western countries. Normally they will do it in the school level education itself. Okay, they used to have this design thinking, not design journey. This design concept that they will practice. What is this design thinking means actually? The students will be allowed to go for an okay a tour, a design tour. Then a design tour, what will happen? They have to okay look around. What is the problem the community that is facing? Okay, what are the things that you have? They have to note it down and then present in a form. This is the problem that you have faced. For that problem, what you are okay going to post it, what you are going to post it, what is the solution that you are going to propose it. So that they will bring it. So bringing this one, what will happen? That culture is inbuilt or rather calculated from the school level itself. Okay, school level itself. Now what happened now here? We are thinking about inculcating this one in the engineering. Okay, now we are doing almost we are okay. Many of the institutions okay had an 1 credit or 2 credit course as part of this in their curriculum as a design thinking, as a design thinking. But it should be there in the school level itself. Okay, this level. Then what will happen? Okay, then what will happen? The social attachment will be there. The social attachment there, then we need not give okay a separate okay a patriotism like songs or something like that. So that's how it is should be inculcated from the school level itself. School level itself. Okay. So that's what the social need that we must emphasize. This we have just give an example for it. Okay. This is thinking. So how to inculcate this one? Okay. So one of the professors here is one of the R&AC. Okay. HVAC. HVAC systems. Okay. Related to the R&AC and then okay heating, ventilating, and then okay air conditioning systems. Okay, he is one of the secretary of that. Okay. Now what happened? Okay, we first brought this concept in just 3 years, 4 years back when he was heading the department, and then we initiated this process. Okay, the students were 2 batch of students were taken, and then what happened? They were allowed to go. Okay, visit. Okay, the vendors, the fruit vendors, no in and around. The fruit vendors. Okay, but what is the problem they are facing? What is the problem they are facing? Now you can see that one either in a cart or in a basket. They used to carry the fruit and then goes all the way in the even in the hot sun. As they go, okay, they are also getting fatigued. And the fruits are that is in the sun. Then what will happen? It is getting the life is getting reduced. Can you design a system? Can you design a system? This is one situation. Another one is that in the harbors, in the even Casimita or somewhere else be there, the fish that is now okay that they got okay. If it is not sold, then what will happen? They will put it in an ice box and then do it. Or even if they take it, even while doing fishing there in the mid of sea, then what will happen? They used to have ice box, and then with that ice box, what will happen? They will put the ice and then fish into that and then fry. The problem is that what, okay, this can hold the ice what you put, their life will be there for 6 to 7 hours only. And after, not only that, because of the water that is there, the container that is built in that is subject to fatigue or other corrosion damage. So that is one problem. Another one is that, okay, another one is that, okay, as they bring it, the ice, cost of the ice is also costly. Okay, and even if they bring it, the freshness of the piece that is not being, okay, it is maintained. So in order to maintain this or give a solution to that one, okay, why I'm telling this is related to the concept of okay, the the concept of this program, okay, this program actually, this phase changing material and smart material. No, so what actually we use in a phase changing material, and as part of it, instead of the ice, can we have this phase changing material and then, okay, use a very light current, okay, since they are middle of it, okay, it's a small battery that should be there, and then we design a system and supply to that, and it is working beautifully. And similarly, the other topic that I gave, okay, for the, okay, the fruit vegetables, okay, we designed a simple a system that can give, okay, a air conditioning, the free cooling effect, such a way that even in the basket itself, with the basket itself, that is affordable to the community, that he designed that one, and then he was given okay, funding really worth about 50,000 for that one. And the why I'm saying that, as an engineering community, we must have, okay, that, okay, the apathy, they will correct term for that, apathy to the social need. Okay, if we have some affection for it, then only what will happen? It will be sympathy will be there. Sympathy is not putting something, we are showing our kindness. Apathy is that what is their need, then we are putting them into that in a proper form and then bring it. Okay, so that's how the social needs that we have to take and then bring it to that. Economics, okay, economics can be defined many ways following some of the key economics, okay, these are not our topic, okay, economics, how far, that is whatever the solution that we are giving, that should be socially, economically helpful, and then it should be, okay. We see the economic activities, okay, what actually, there is the primary sector there, and the tertiary sector there, and then the secondary sector. So the primary, what I actually mean by this, okay, primary sector, simply speaking, primary sector is the sector of economy which uses natural resources, something like mines and all this. Natural factor is crucial today. Agriculture, allied activities, mining, fishery, all this one. Okay, we should give naturally, okay, our knowledge to give bring a better economy to that. Secondary, using manufacturing, using this as a natural resources and then providing that one. And tertiary sector, the service sector of the government called as related to service of various kinds like education, health, banking sector. So all this, our role, engineers' role should be there to bring up the economy. Okay. So the economy, how do they bring up this? Bring out this, following this. Quality education, clean and efficient energy, sophisticated infrastructure, improved social amenities, increasing pace in GDP, ability of self-production, good economic stability. Okay. So, but as an educator, we are okay more concerned with this. Okay, these these things. Okay, quality education, clean and efficient energy, sophisticated infrastructures. We must give a quality education such that the socio-economic situation that is being maintained, and then bring it to a level such a way that it must end up with a total prosperity to the country. How can we do it? Okay, this is what, okay, we are differing most of our cases, especially in our state. Okay, see, that is, we can, one way we can justify this. Okay, instead of giving a fish, okay, let him learn to how to fish it, that we have to clear. So that's the work of engineers, that is the work of the teachers community, teaching communities, that is what I have. Okay, so most of the major issues that face the country and the world, such as climate change, water availability, energy security, need engineers, all this one, this topic, that is what will happen, the phase changing materials and all these things, okay, helps. Okay, why I'm saying this phase changing material and all these things, okay, this is there in our culture, already there. Now, what is the ultimate objective? Ultimate objective is in the phase changing material or easy objective. Okay, take one form of okay, he has a form with the stimulus of something external. It gives a beneficial effect to this. Beneficial effect. If you, any of you would have visited okay the ports, even Agra port, okay, Agra port, or in Rajasthan, we go there. There are many ports that are available. Okay, what you can see there, they don't have. They have a very natural air conditioning system. Natural air conditioning. How they maintain it? How they made it? Okay, because of even we don't have the science, or rather we don't have the technology. They don't have the technology at that time. They maintain it. Okay, so that is what will happen again. The phase changing concept is already there in that itself. Say anything we liquid, if we are looking for a solution, normally we look out in the nature and then get it. Even the phase changing also, how it comes. Okay, we see that one. Okay, how it comes. Okay, see, there is a type of a fish or something like that. Even we can say simple way. Our Tungumujimaram. Okay, Tungumujimaram. Okay, I don't know what is the botanical name for it. That is a very good kind of some basic. What is that one? With the temperature falls down. Okay, what will happen? All the trees, okay, leaves are getting okay in a summer mode. Okay, when the sun is there, or even the sunflower, okay, it changes the direction based on it. Okay, something like this. Okay, all this. Okay, even the pachodi we'll call it as okay in Tamil. Okay, pachodi. What will happen depending upon scenario? It changes. All these are the examples. Okay, God has designed already the phase changing concept into the earth, into the nature, and then only thing is we have to realize this and then make it up, make it to happen. Okay, just 2 minutes time, please share with me. Okay, let me have a cup of water and then come, please. Well, that is the quote that is being okay. Yeah. So ensure that, okay, ensure the natural resources to each and everyone. Okay, engineering makes it important contribution to the economy, both from the direction, addiction. Okay, these are things that I'm leaving out the PPT to you that you can go through this. Okay, so technology innovation, okay, how did that? Okay, education, production, construction, information technology, all these furnaces, all these one, our role should be there. Engineers should be involved. Engineers must be involved in all these processes. Then only we can bring a better prosperity to this one. Okay, okay. These are self-explanatory. Just I am rushing through this since I have the other the conceptually oriented. Okay, conceptually oriented. Okay. So all this, okay, what happened now here? This is there's something like this robotics. All this that comes to this. Okay, a lot more now had come. Okay, that is already there. It is started coming out. We have our lab now. Okay, we have already the 3D printing concept, IoT. That's what I'm going to do later. That's it. Synthetic biology, synthesize the biology, and then okay, brain enhancement, nanomaterial, etc. All these are comes into all the comes into this one. The brain enhancement, all these things. Okay, the smart material plays a major role. Smart material plays a major role in that. Even the catheters, what we are using inside our body, okay, that also has a smart material that helps, or nanomaterials that helps us, okay, treating the cancer. Okay, the targeted medicine. Okay, medicine that is being sent inside to target a particular part of it, and then okay, that's what it gives us that okay, we can add and then bring it. All these juggling can be done. All this juggling can be done. And then this is something like to treat the cancer, how the targeted medicine that should be there, and then to bring the part, okay, mimics the part, okay, exactly to the nature what is needed. Okay, all these medicines, all these things, okay, that is given in that form. Okay. Okay. Can you get it there? Okay. Okay. So this there. So what happens? These are recommendations that we can give it. Okay, assets. So a conclusion: every section of economic activity, almost 11 is there. economic as role engineering, challenges for based in the country, energy, infrastructure, any, okay, and that's what the ABJ emphasis much, okay, we should focus more on the energy point of view, and happy that the current government also giving lot of emphasis on that and bringing more solar power into this one and then bringing this, okay, this, okay. So that's what, one final thoughts, okay, no engineers, no development. It is something like a bike without head, bike without a head. Okay, so that's what. Okay, we can bring the world to us. Okay, that's what it is given here. Okay, bring the world to us. We'll bring the world to our hand. Okay, by means of. See, that's what it is symbol that is given there. Okay, by means of. Okay, bringing it. So that's the thank you for the presentation as far as the Engineers Day. Once again, it is my pleasure to invite present the topic that is okay. Now let me move on to the next topic that is called as the application of a smart material. Whether the screen is visible now, Sagameswaran? Application
Yes, sir.
Yeah, good. Okay.
Okay, ma?
Yeah, it's okay. It's okay to you? Okay, then I can do it. Yes, yes. So application of smart materials in magneto-rheological abrasive flow finishing process. Okay. Actually, when Sanma Sundarma asked, okay, I used to have and also inculcate the same thing to all my fellow scholars also. If a contributory work is not there, I don't accept any of the invitation to present anything. Okay, so I searched myself with that. Okay, and then what happens now? All of a sudden it came up in my mind yesterday only. Okay, why we have done something on the smart materials? Okay, and then okay, that's what it is. We bring the concept of it, the smart materials in MRL. Okay, so what is the role of these smart materials? So I think many of you, anybody would have is like this. What is this? This is something like, okay, what is there? Okay, why we need a smart materials? That's what I am amazed with my concept. So this is something like what we used to get a flower in our early days. But like somebody will there in the okay, this part there no, okay, here this part is there. Here what happened? We will yes. Can you hear me?
Mohan, sir. Mohan,
Yeah,
sir.
yeah.
Screen not visible, sir.
Not visible.
Yes, sir.
இது வந்ததே
Previous session by the sir.
Madam, good morning, madam.
1 minute. I will stop share and then come back again. Okay.
14th program too.
Now it's visible, sir.
Visible
Yes,
now?
sir. Yes, sir. Yes, sir. Yes, sir.
Okay.
Thank you, sir.
So this is something like, okay, what we used to have it, we used to get a flour, okay, whether it is rice or whatever it may be that. Those days we don't have any machines, something like this. Okay, what will happen? Somebody will put the grains whatever there, and then what will be this will be getting rotated. Okay, the concept is what is the need of this? Why is you present in this one? This is the concept is that why we need smart material? What is the emergence of the smart materials? Emergence of the smart materials. How it has come on? How it is come on? Okay. So now what this is what okay. What will happen now? The total human effort that somebody will rotate this one, somebody will rotate this, and then somebody will, or rather a single person will rotate and then put the grains inside and then this. So once it are there, okay, what will happen? Okay, put the things here, put these things here, okay, in the hopper. This is used to have now, even nowadays we used to have. Okay, we'll put the okay grains over this, and then what will happen? Instead of the manual effort, what will happen? Replacing with a motor, replacing with a motor. So the rotor motion that is given here, and we are replacing the human effort. So somehow now the fatigue of the mission or man has been okay. So that's what okay. That is the one step. Still going further, okay. I don't need anybody in that. I don't need anybody in that. I don't need anybody's help there. But what will happen once I put this or everything here? I should get a bag of okay, whatever you needed. a flower that is needed. That's how we are getting Ashirvadata, all these things are we are getting. Now, why we need this? How it is possible? That is the automation that is happening there. There are some evolution and the revolution that has happened. Evolution and healthcare. So evolution, what happened now? Evolution that gives, okay, evolution that gives nothing but, okay, evolution that is just adding whatever we had, this is we had a early carriage. Then what will happen? More fanciness is added, and then leads to the aerial work. But the necessity is the mother of invention, as already know that. Okay, but evolution, what is that? Okay, even though the evolution, what is there? Okay, we have made some okay arrangement, ornamental arrangement only. But what happened now here? Instead of that, we have made total. Okay, this total it's instead of a bullock or instead of a horse that is pulling that. Early automobiles bringing this steam into this one, steam engine initial one, and the later in the combustion engines, all these things. Okay, so evolution leads to revolution. So another example is the vintage analog Ford that is there normally. What will happen? We have to ring this one. We are doing a little bit cosmetics to this one, patch digital phone then, and finally we are end up with the smartphone. Even in the smartphone, what are now here? Okay, except that's normally used to joke it. Okay, except okay, Smith. Okay, grinder, mixer, and grinder, everything is available now here. Okay, camera, phone, everything is available here. And I don't know, in some days, okay, we may bring something inside this also, such a way that this also will happen. So that's what this evolution and revolution is happening means. This is how it is happening. Okay, this is what. Okay, earlier industrial revolution. Okay, early industrial revolution. We have introduced mechanical production machines powered by water. And then what will happen? Beginning of century, we have the transfer lines. And beginning of the century, then what will happen? Industrial revolution through the use of electronics, IT, further progression is automation there. And then it is there. But even it is there, what is the total concept behind this one? Okay. Initially, we gave power to the machine. Okay, we gave power to the machine. And then what will happen next? We give some sort of sense to the machine. Some sort of a sense to the machine. That some sort of sense in the sense that, okay, okay, what will happen? You are giving electrical energy, and then it will send something. But what will happen? This data, whatever, no, that will, it has a data. Then even we can say that it is able to sense it. But later what will happen now here we take the data that is there and then process this one. To process this again, what will happen? We need a human being. But what happened? Even going into this in the 20th century, we are bringing IoT into that. What will happen? We make the machine to sense its surroundings. Sense its surrounding, and then calculate, send the energy, send the signals, and then take the action, take the artificial action or the intelligence. We are bringing intelligence to that. We don't have an intelligence. Whatever we feed, that only will, whatever we feed the program inside the it will work. But here what will happen? It will take its action on it. Okay. So that is the Internet of Things. Now what is that? In all this, from here, what happens now? As we progress this, we are bringing more and more development in materials only will result in all sort of these things, either energy or whatever may be the sector. If there is a revolution in the metal, okay, revolution in the materials technology, then only all these things will be possible. Anything that will be, we need some material there to realize this one. And that was okay. So the level of complexity increases. There is a changes in the material, changing in the materials that should be there. To bring this concept, okay, to bring IoT and then cyber physical and all this augmented reality, real-time intelligence, all these things together, we need, okay, a materials that can sense on its own and then give it, okay, give it up on its, okay, give the, okay. That's what this is another form where the manufacturing paradigm changes. All this because, okay, bringing. So one such material that is there that is helping is that one nothing but the smart materials. Okay. So that's what, okay, the earlier stages of how the revolution there and the machine that is bringing this all this into concept. So So we bring these materials. I need not emphasize much on this one. Okay, I'm just rush through this one. Okay, and make it happen. Okay, these materials may be of any of these one wood, metals, polymers, ceramics. If we compare these properties, compare their properties. Okay, from okay, we will come to this these cases, the low carbon steel, stainless steels. Okay, and then heap in the HIPS process, all these things. Okay, what will happen? It has even if we take a stainless steel, very good, excellent properties in all these things. Okay, all these things. Okay, but it has a good one. Okay, but it is a poor. If we compare low carbon steel, it is poor on that part. Okay, now can we combine all these things? Okay, these materials there, it can provide as a virgin and then it will remain there. Okay, it will remain. But can we have a metal which is a reactive to this one? The metal that is a which is reactive to this one. There it comes to smart metals. Smart materials. Okay. Or safe memory alloys, whatever. Maybe that will be bringing this one. Okay. Reactive to this interest and then bringing this one. Okay. So what is that one? How would they react? If there are some stimuli, there are stimulus. There are some stimulus. The stimulus make them to materials sensitive to war. These are stress, temperature, moisture, pH, electric field, magnetic field. Some sort of energy that is given there that will make them to realize what they are, change their position, change their shape, and then changing in their shape that could be utilized, changing in the properties that could be utilized for our engineering application. That engineering application satisfying the societal needs. That is the smart materials are the materials that can significantly alter one or more of the inherent properties while the application of an external assembly on a controlled patient, So without any control there, means then what will happen? It is not useful. Okay, that's what. Okay, we can find a smart is it's a significant material. It is measurable. Okay, appropriate, and then result oriented and time oriented. Okay, the smart we can bring that into these levels and then make it. Okay, now we bring this one here. Bring these properties here. Okay, the because of this only, the smart material plays a major role in this one. Smart or intelligent materials that have to respond to stimuli and environmental changes and activate their function according to these changes. Stimuli like temperature, pressure, electric flow, magnetic flow, light, mechanical, etc. can ignite. Okay. So every one, each and every one, it plays a major role in the what we are today and how the quality of life has increased or improved to a larger extent. This is because of this. This is because of this. Okay. நான் கிளாஸ்ல இருக்கேன், ஆன்லைன் கிளாஸ் போயிட்டு இருக்கேன், அப்புறம் கூப்பிடுறேன். ஓகே. Smart or intelligent materials are materials that have to respond to stimuli. The stimuli like temperature, or everything, the light that changes on that makes it. Okay, that is one quartz crystal that it changes the temperature. Then crystals which is having a periodic atomic nature instead of quasi-crystals. Quasi-crystals means that is there will be a regular arrangement at a particular period of time. After a particular period of time, then what will happen? The order in which the atoms that are arranged will change. That is called as a quasi-crystal. Using these quasi-crystals, lot of advancement in the field of communication engineering has happened. Okay. Yes, Senthil Kumar. Senthil Kumar, eyes raise your hand. Okay, I'll come to this one. Okay, any questions there? Then I will come to that. Okay, at the end. Sensing material devices, actuation devices, control devices techniques, all these things, the self-diagnostic, self-control, self-healing, self-healing composites are there, shock observers, we have done a work on the shock observer also in the early part of it, and then, damage arrest, something like that, these things are possible with this one, role of these merged materials. So the system consists of data acquisition, and then data transition and command and control unit. And this is for an advanced system and a data instructions and action devices, the advanced level what I am taking there. So this how the smart structure will be something like this. The smart structure, how it will be, the material that are used is that. This is here we focus on it. Okay, it may be a piezoelectric electric material, electrolytic, magnetoelectric, rheological material. This only I'm going to check it in my study and how it helps us to solve one of the problems. I have biometric materials, smart gels on this one. Okay, so what will happen now? Some of our stimuli that is being applied on this in some form, piezoelectrically as a pressure that is applied that will change in the current, electricity that is a capacity will change, magnetism the EMF will change, and something like that. This goes on. This goes on. If there is a changes on this one, how could it be utilized for an engineering application? That is our the piezoelectric subject materials. Okay, this already many of them would have started that. Okay, that's what I'm rushing through that. Okay, I need not. Okay, we have a lot of things are there to discuss. The subject to an electric charge, a variation in voltage, piezoelectric material undergoes some mechanical change and vice versa. This used in the our cutting force measurement. All these things that are piezoelectric electricity that are being used to measure the cutting forces, forces already. Electricity forces. Okay, the material has the same property in the material, but their mechanical change is proportional to the square of the electric field. This can always produce displacement in the same direction, displacement in the same direction. Okay, so it's something like in the sources, light sources that they will use it. Okay, the magnetoelectric material subject to a magnetic field and vice versa. This material will undergo an induced mechanical state. Consequently, it can be used as a sensor and actuators. Okay. This is another form of applying a mechanical or rather the magnetic field out there. Okay, here it changes. Okay, here it is a changes. Okay, the fluid is there. Fluid. Okay, fluid. Okay, a rheological material or rheological fluid, if you say that. So what happens? So these are liquid phase which can change their state instantly through the application of electrical or magnetic charge. Magnetic charge. These fluid may find application bridges, shock absorbers, dampers, okay. These are already that is being used. Shock absorbers. We did somewhere, okay, your project, your PhD, one of our PhD in shock absorber using rheological fluids of 25 years back. 25 years back, we did a work on it, okay, for a damping purpose that has been sent out. That has been used for it. Okay. Now here is that, okay, the electromagnetic field, what will happen? What is that? A rheological fluid means subjection of an electric or magnetic field that changes its direction, or rather something like that, changes to liquid to solid state, solid to liquid state, something like that. This will be happening. If we take this one here for an engineering purpose, there it ends up, okay, there it ends up with other application. Here that is called as a magneto-rheological abrasive flow finishing process. That is the topic we are having. Okay. This is the thermoresponsive materials. Okay, it's used in the almost the stats and thermostats and parts of automotive and aircraft vehicles there. Okay, and now some of electrochromic materials. Okay, fullerances, biomaterials, smart gels. Okay, smarter gels there, and then shape memorialize, all these things. So they come to this one. Okay, now what happens now? So taking this rheological fluid, apply this for in the machining process, and then get it a nano level finish for an biomedical application, That's what happened now here is that a magnetoelectrical abrasive finishing process that is being set up, and then and the process you use is a machine, a stainless steel. Bring this to a nano level, and then at the nano level surface, how it is a biocompatibility, how it is improves its biocompatibility. Okay. So what is that now? Okay, conventional machining process utilizes hard tools to remove the material, thereby produces normal stresses. Sometimes they may lead to generation of micro cracks. These micro cracks reduces the life of this. Okay, the fatigue life of this is getting affected. If we want to improve the fatigue life, what will happen? We have to improve the surface finish. Improving surface finish increase the fatigue life to very level, to be high, very level, since the initiation of cracks that is being. So conventional machining process find difficulty generating required surface finish, and it stimulated developments of advanced machining processes like magneto-rheological abrasive process, which has both the magneto-rheological finishing and abrasive finishing process. Okay. So what happened now here? Magnetoreological finishing means we'll send the fluid over a surface and the fluid itself create the required finish. But if we add abrasive along with that one, then what will happen? Now abrasive flow there, and then what will happen? This abrasive flow finishing, that is a fluid that is mixed with an abrasives that is being passed through on a surface, passing over the surface creates a return. But what will happen now? There may be some difficulty as the abrasive moves. What is the guarantee? How can you ensure that the abrasives that it has moving over the parts, and there it comes the abrasive flow, reological abrasive flow process. So what happens now here? We'll make the sum of the particles inside when we pass and applying an energy, okay, either electrical current or magnetic force. Due to the magnetic force, the particles will be pulled, and then the particle inside will carry some amount of abrasives, and this is allowed to pass or rather move over this one. This is how the process itself is there. Okay, so that's our micro and the honing process, safe and silent with each of these traditional process that is there. But an advanced process, all these comes under this one. Okay, this is being generated by taking in one of the a winter program, okay, in IIT Kanpur. Dr. B.K. Jain, okay, I think sometime B.K. Jain also came to Sai Ram Institute, I hope so. Okay, he developed some of the process. We adapted some of the process, modified it, and then modified to apply to the biology. Okay, we have taken the concept, applied, and then a total process has been developed, and then it is used. Okay, Kadiresan has done. Okay, Kadiresan is a professor there in Padmavat Engineering College. Okay, has done his work, and then continuation of the work is another work that is about to be submitted in another 6 months. He will submit the another thesis. This is also part of this one. Okay. What happened now? We are going to concentrate, focus on more on this MRAF. Okay, since if we discuss this process, this itself a whole full lecture we needed. I don't want to just straight away I'm going this. So these are the process. What is the maximum level of surface toughness value? Surface toughness value that we can bring it. Okay, grinding, honing. What is that? Okay, this is in the nanometer level. It produces in the micron level only. Anything that is less than 100 micron is not able to produce it. There it comes. Okay, here. Okay, as we move on to this. Okay, more and more cost comes. More and more cost comes. Okay, these processes are cost intensive. The machine itself needed. Instead of that, okay, applying the low concept, okay, cost automation, automating this process with this one. Okay, we can able to get it. So, okay, this is how the process, something like this process. It has 2 cylinders. Okay, top hydraulic cylinder there, and then we have a MRF cylinder there. Okay, MRF cylinder will have the fluid. Okay, MRF cylinder fluid, and this is the workpiece where the workpiece that will be held here. Workpiece will be held here. Okay, workpiece will be held. And then whatever setup we have at the top, we have at the bottom also. We have at the bottom also. Now what happened now? Okay, I'm more specialized in the area of hydraulics and pneumatics. Okay, and then that helped us to carry this work in a better level. Okay, so what happened now? Say up to these levels, I can use the concept of hydraulics into this. Inside these 2 cylinders, we have the MRF fluid. Okay, MRF smart fluid. This smart fluid, what will happen? As I apply here, you see that? Okay, as I apply, okay, the smart fluid that is being pushed here through this one and goes over this, goes into this a channel. When it goes to a channel, then what will happen? We apply electromagnetic coils that, and if you apply electromagnet here, and then what will happen? The particles that are mixed in this will be pulled towards this side, and then goes over this part. As it goes over these particles, okay, the particles will have iron particles, carbon and iron particles. These particles will carry abrasive particles. These abrasive particles will slide over this, and then what will happen? Create the required phase. And as this fluid comes here, next, this is the turn of this cylinder, and then what will happen? This goes here. Okay, what happens now here? 1 cylinder movement. Okay, next what will happen? During this cylinder will move down. and then once it reaches this one, this cylinder moves up, another cylinder, then at that time this cylinder will goes up. Okay, there is a sequence through which it is being done. So since it is a sequence that is being there, what will happen now to automate this? Okay, how many cycles? Okay, how many times the linear movement of this cylinder occurs? How many times the linear cylinder movement of this cylinder occurs? We need to count this one. We need to count this one. Counting these, all these are happening inside. We can count it with the help of a solenoid that is being kept inside. But what happens now? Counting this solenoid, sometimes we may mistake it. But this is being automated with the help of a PLC. Okay, put this PLC, count this total automation that is being enforced with this one. Okay, this is how we developed the setup. Okay, now how this? Okay, what is happening inside? Okay, even though we have so many things that is happening, the most critical part is what is happening here inside this part. This makes the process so beautiful, so beautiful. What is that actually? So the fluid as in motion here, you see that as it comes here, this part, as it comes here, okay, these are the particles. These are the carbon in ion particles. It is mixed in a liquid, and then what happens? These are the abrasives. The bigger ones are abrasives. Bigger ones are abrasives. Now what happened now here? Up to these are randomly oriented. The particles are randomly oriented. But as it comes over here at this part, what happens now here is that it forms a chain. As you can see that it forms a chain. This chain, what will happen in turn, carries these abrasives. Okay. So subject of this field, okay, what will happen? The viscosity of the fluid changes. Viscosity of the fluid changes means what will happen? The particles are making a line with that. It is a coherent on that. When it is a coherent, the particles are coherent, then abrasive particles are falling in line with that. Falling in the line. With this falling in line, what will happen? These abrasive particles goes over this, and then current is into minute movements, and then minute material movement that is being. That's what it is called as a rheology. Rheology branch of science that deals the study of flow and deformation of material under applied force. That is especially fluids. Okay. Magnetorohological fluid is a type of fluid whose apparent viscosity greatly influenced by applied magnetic voltage. The rheological behavior of MR fluids can be manipulated externally by application of some energy fields. Okay. So, in particular, yield strength of the fluid can be effectively controlled by the intensity of magnetic field, which consists of micron-sized magnetic particles, which is being mixed along with them. Okay, that is carbon and ion particles or ferrous particles dispersed in a non-magnetic carrier medium or base fluid, usually paraffin oil, silicone oil, mineral oil, that will, or even sometimes water. Okay, will not be so effective water that we say. Take this fluid, mix these ion particles, and then along with that one add the abrasives. And as these fluid that is containing this abrasive particle subject to an abrasive or the magnetic force, then what will happen? This will make the process to happen. Okay. When it happened here, this is what we have used it. Okay. We have used the abrasive particles, both are okay. Silicon carbide, cerium oxide, aluminum oxide, okay, aluminum oxide, and then boron carbide. Diamond also used, but we have limited ourselves with this one. Okay, silicon carbide, cerium oxide, and aluminum. These three. Okay, base fluid is silicone oil or paraffin oil that is being used. We have used the silicone oil for this purpose. And then what will happen? Okay, in that using this surface material of the using this, how it is effective in a biocompatibility. Okay, so for this one, okay, we have selected material is a 316L. This 316L, okay, that is stainless steel 316L. Okay, that is being used in an East metallic biomaterial with a sensible biocompatibility. These are finding in almost in the application whatever it is being. Okay, cardiovascular, stent, artificial valves. Okay, so sometimes somebody may have a heart attack. Heart attack means immediately they will go and then do the angiogram. And do the angiogram means in the okay, there will be some blocks. The blocks means what will happen now. The block is manageable. Then okay, it is a manageable level. Then what will happen? It is away from the heart. Then what will happen? They will put a catheter inside, put a stent, and then make the deposition of the fat inside that is being prevented from coming inside, and then the flow is there. Okay, what is up now? We have a vein there that will be of 3 mm. Inside diameter is 3 mm. 3 mm. Inside that, if the fat deposits, then what will affect the area that is being getting reduced. Because of that, what will happen? Pressure increases. Pressure is nothing but force per unit area. The basic concept. Okay, pressure, force per unit area. As the area, force is same. Okay, the flow which this that goes, the shear stress is same. But here, what will happen? Area is getting reduced. The reduction in area, effective area, because of this blockage, that makes the pressure increases. Pressure increases. To overcome this one, what will happen now? We'll put a material here. Push this up. Push this up. Okay. Yeah. Push this up and then put the stud. Put the stud. Okay. Like this goes up. Okay. So that's how we have made it. This is the plan. Okay. This is the tool. Okay. This is the actual setup. Okay. This is the actual setup that is being there. Setup which is utilized. Okay. This is the top cylinder. This is the rheological number of cylinder, lower cylinders. All this being connected with an external by means of solenoid, and then the PLC as a separate cabinet that is being made, and then there is aligned with this one. This is the total setup. This is the total setup. Okay, total setup. Okay, one student, MD student, is so familiar in hydraulics. Okay, he helped in developing all these things, and then bringing another electrical engineer that you have brought it, and then coupled this total thing, everything that is being made here. And then what happens? It's made. It's available. It still was available. It was available sometime before in MIT. Now it is moved out to another scholar and doing his work for the another the extension of this work further that is being carried out. In another 4 or 5 months, it will come back again. Most probably, it will be back in MIT. Okay, my parent institution there. I did this work. I did this work. This is one of the contributions I made to my institute and to do further research on that work. Okay. So how it is there? Okay. So what will happen? This is the technical part of it. Okay. So what will happen? Bringing this design concept in this experimental design of experiment concept in it, and then selected at 3 levels. Okay. And then putting this on there. Okay. What will happen? This is how the fluid that is being made. Yes, we can stir there. It should it is very difficult actually. It must be very patient enough to mix this one. It won't mix easily. You have to mix it for hours, and then see the homogeneity, and then that is it. Okay. Yeah, it takes your patience to a very large extent, Okay. So this how it happens. Okay, this is the or rather, this is the material that is there irregularity present on the surface of a material, and this what will happen now. The base material, the base fluid that goes carrying the iron particles, along with this the abrasive comes. As this abrasive is moved over here, it's sheared off this part and then moves over and then goes over. This is okay. So bringing this abrasive along this line, making a line, making a chain on that part, and then that makes the okay. So these are the results that we're looking for. Okay, one people think that you must notice out of this one. Okay, maybe that we can able to make it to a level of 50 nanos. 50 nanos. Okay, 50 nanos of that. That is so beautiful. It is very much appreciable. It may take a lot of time, lot of cost to produce this level of surface finish, and that too over a bigger part. Small part you can make it, but a bigger part if you want to make it, that will be very difficult targets. Okay, so that's how the how it is another study I didn't carried out. These are I'm just leaving it. Okay, this is not much importance. Okay, anybody or how the experiment that is being carried out, that is objective of it. Okay, the surface finish that is being measured or rather measured with alpha. Okay, measured with alpha on a daily sub CCS system that is available here. And some more lessons during my actual level we are bringing nano level surface finish measurement in mechanical department itself. Okay, this facility is also available in the mechanical department. This is the view of a image of the porous particles and the abrasive particles. See the difference how it is there. Okay, this is on 18 micron, the 400 mesh. Okay, somewhere similar to this one. So this is how the voltage. Okay, what happened now here is that the vary this. Okay, what happened now? The parameters that we can vary the hydraulic pressure, okay, voltage, and how many cycles. How many cycles? How many cycles? How many times you are pushing this piston in and out? The cycle that makes that cycle voltage and the pressure that makes pressure up to a certain level only it will make a difference. But these will have a direct contact, direct relationship with the surface finish. What is the surface finish that is being? So this how that are okay. The how the another study that is being there. This is the surface what you made it. Surface that is made it. Okay. Before you can appreciate this. Okay. What is the level of surface finish that is there, and same level of exhibition. Okay. Magnification. This is the finish what got it. Got it. Okay. This okay. The surface profile instead of one particular part inside the three-dimensionally we are taking along the x and y direction and measure this one. Okay, put in this tab. Okay, the 3D level prop. Okay, this is the hydraulic pressure that is making on it. As the pressure increases, then what will happen? You can see the plateau happens. Okay, almost it is the constant. It is a straight line that is being maintained. Okay, so the shear thinning effect caused on it that makes this to happen. And this voltage is that okay, voltage that okay, as you increase the voltage and PA level and then goes up. And that also what will happen now, okay, this is going and as you see that it is going in an exponential way. We limited ourselves only at 12 volts and then see that how it happened. Okay, and the number of cycles. Okay, it maintains the plateau over certain regions, and after that it increases. But the increasing that one is not very normal, very normal, as you can see here. And then what will happen? It is somewhere around 54 or so, and then what will happen? It is a 56. Only 2 micron, 2 nano level only. There will be a much increase. Okay, that's not much. But up to certain level, it increases to a very long level of reduction in the surface finish, surface roughness that is happening. That is a so that's another graph that is showing all these things. That is a part of this one. Now this is okay there. Okay, what happened now? What is the use? Okay, we finish the surface there. What is the use? Where it is going to be used there? So there it is in the biocompatibility. Okay, biocompatibility. Biocompatibility means as you put this system inside, okay, the stem inside, and how far? Okay, what will happen now? It's a foreign body. A foreign body that is going on it means definitely there will be a reaction will be there. It is something like a dog. A dog from other teeth comes means what will happen now? It will produce all sort of nonsense. Okay, something like this, and a foreign body put inside that. It should, even though it is compatible, and over a period of time, then what will happen? It starts producing problems. Okay. Now, if we have a good surface finish, how far? Okay, especially in the case of the compatibly as far as okay related to okay mainly are that okay the cytotoxicity, okay, absorption of proteins, bacterial ingestion. So how these bacterial ingestions and then how far it is taxing the okay toxicity level increases that one. That okay, what is its effect that we have studied, and that leads to a lot of these are okay. Okay, anything okay, even if you have seen that in the pandemic region, okay, how a vaccine that is produced is goes how many rounds of okay. But what will happen now? We cannot, as an engineering profession, we cannot straight away do it. But instead, what will happen? This will help us to go for it. Okay, in an okay offline mode, not inline mode, an offline mode, not online mode, in an offline mode. We can test and then create a result. That result may be useful for them in their future study. That's what we have done it. Okay, how this is compatible? How it is compatible? So this compatibility that we are taking it. Okay, I will give that what actually will be what will be cytotoxicity. Okay, what is that one? Okay, there is a slide there. Cytotoxicity. Okay, what is that test now? Okay, refers to the quality of being toxic to the living cells. How far the surface creating this toxicity. Toxin removal is the problem. Okay, anybody, okay, if we are removing the toxin beautifully, then we can have free from all sort of troubles, all sort of illness. But how to remove this one? Okay, if you are removing the toxin, immunity level increases. If your immunity level increases, means no corona will come. No corona will come on. So okay, so for this cytotoxicity, okay, what will happen now? That is that these are the osteoblastocyte cells and all the cells. these cells has to be studied. Okay, it's a very difficult one. Actually, the scholar has gone through that. Okay, you will take the part, okay, machined part, will rush through it, and then without forming any surface layer over it, and then go for it. Okay, that should be put on this one. You will take from here to Satyabama and then do some tests and then bring it. So such a level, okay, he has gone from here. From here to this one, will within half an hour we'll reach it. Okay, so that's the level he has performed it. Okay. So okay, what is that? The MTT has said this is a principle that is based on reduction of soluble yellow salt into the purple. Okay, then what will happen? You should not form a layer. To study this, the MT assay principle, that is another biotechnology principle that is comes into this one. Okay, how it is being utilized. So these are the tests that is being done. Okay, what will happen? I will give the glimpse of it. Okay, glimpse of this one. What happened now here? The samples, 4 samples that are being set. Okay, 4 samples that are being set. Okay, one control agent without any. Okay, without any there. And then okay, the samples with the 53 nano, 62 nano, 70 nano, and then 178 nano. 179 almost okay, the acid is the received material without going for this one. Acid if we go for it, we will go for it. Cell viability is very, very less. That is toxicity level is very less as we bring the nano laboratory. How it is possible? With the help of the smart fluid only, the smarter fluid only. Okay. So that's how okay, cell viability that is a decreases with the parts with the lower nano. Okay, similarly cell preparation, that is the how the part that is a layer that is proposed, that is also very good result we got in the case of nano levels. Okay, and then okay, absorbance of cells on the surface, absorbance of cells on the surface with the 4 specimens. Okay, what is the level, and over a period 7 days it has to be kept. It has to be kept. The sample has to be kept in 7 days and then see the result. Okay, over a period. Okay, that is what there you see this one. Okay, more protein that is happening. Okay, what is the use of these proteins? Okay, increasing these protein levels as we bring this one somewhere. Okay, it may not be useful in the case of an where it may have adverse effect in case of stent that is being kept in the vascular system. But in here, something like the implants that we are making, that is suppose somebody's bone is broken, then what will happen? We are putting the plates in that one. In that plate, if we make the proteins that is adhere with that one, it will make it okay. That will be very good. Okay, that's what. Okay, so that will make it like something like this. This will be more useful on it. Okay, so like this protein absorption like this. Okay, now I will give the results. Okay, I will give the result. Okay, so the bacteria is also reduced to a very large extent. That is the beauty of it. Beauty of this experiment is that the E. coli, all these things. You see this one. Okay, sample A, which is having lower level of nano RA levels. Okay, what is that one? Is 28. But all these things, what's the start increasing? The number of bacteria that is sticking with the surface started increasing on it. So okay, so this are okay. What are now? Okay, let me. Sorry, I'm rushing through that one. Okay, these are the images. Okay, how the E. coli, the bacteria know. Okay, how much that is sticking with the surface, that gives it. Okay, and this goes are like that. Okay, all the other symbols. Okay, the K. pneumonia, another bacteria, how it is reacting to this one. Okay, and like this. Okay, it will be the bacterial invasion test. Okay, that is also so good results. Okay, so as I conclude that, okay, what I already have done it. Okay, so I touched almost all the parts of okay the engineer's day, and also the what is your role, and then how this smart fluid that is being used in the case of okay for our engineering application, how that is being used. Okay, smart material that is being used for an experimental study. Okay, this is what I plan to do it. Okay, and any queries there in the PPT, I will leave it there. Okay, you can go through that. Even then, mail ID is also there. If any doubt is there, okay, you can mail me. Or any specific doubt you want to clear it now, okay, I am ready to clear. Okay, so thank you for listening patiently for almost more than 1.5 hours, almost 1 hour 45 minutes. Okay, I hope you would have served this purpose. You should have served the purpose what for you came here. But for thank you. Yes, Sanmasudram. Sanmasudram, okay.
So,
Yes.
okay, sir. Thank you, sir. It was really useful to the participants. So, moving on to question series. Yes, thank you, sir. Thank you for your presentation.
Yeah.
Participants, if you have any questions, you can put forward your questions in the chat box, please. And the feedback link has been posted in the chat box. Please make a note of it. It will be active only for 45 minutes. And now it will be activated after 10 minutes. Please make a note of it.
Any queries?
And participants, kindly, if you have any queries, sir is there to answer you. So you can unmute yourself and you can interact, or else you can post it in the chat box, please. So, okay, thank you. If you have any queries in future, you can interact with
okay,
sir.
ask them, we post it. Okay.
Yes.
Right. Okay.
Sure, sir. Sure, sir. Thank you, sir. Thank you for spending your valuable time.